Hi, and welcome to classifying numbers. And you would think, wait, there's different kinds of numbers? Yeah, of course there are. Uh, in fact, we're asked to find out, well, what kind of number is pi over 2? Is it whole number, integer, rational, and irrational? I'd like to uh, walk through what the different kinds of numbers are. I'm going to move this aside, and I'm going to start broad. I will start broad with real numbers. And yes, there are imaginary numbers, but we're just talking about the real numbers. And the real numbers are split between the rational and the irrational. Um, Now, a rational number is really just a fraction of integers. And that's simply like an integer is just a positive or negative whole number. Like 2 is an integer and 3 is an integer. There's a rational number. Um, -1 is an integer because it's the positive and negative whole numbers, and 4 is an integer. I could take uh, something like negative 7 and 10. So these are all fractions made of integers. And what happens with all this, when you turn them all into decimals, they turn into decimals that either end, which is called a terminating decimals, like this one. 1/4, we call it a quarter, which is 25 cents, so that's 0.25, and this one's negative. But the point is not that it's positive or negative, it's that it comes to an end. That's a terminating decimal. All right, terminating. And if I look at this other one here, 7/10, that's 0.7. It's going to be negative because our fraction was negative, but it terminates. Now, the 2/3, if you put this into a calculator, you would find this is 0.6666, and it just keeps on going. And that's a repeating decimal. But it has a pattern to it. It either ends as 1/4 and 7/10, or it repeats. It has this repeated pattern. Now, the irrational is they are non-repeating and non-terminating. So the classic example is pi. That starts as 3.1415926535897, and so on. That keeps on going, but notice there's no patterns to this. So it doesn't it doesn't follow this where nothing repeats and nothing terminates. Now you can have square roots on this as well. You can have square roots of I'll bring this up a little bit. Now to continue this, you could have the square root of 1. That's 1. That's rational. It's fine because we can make this 1 over 1, and now it's a fraction of integers. Or we can have the square root of 4 because that's 2, and that could be a fraction if you want it to be. But in between the square root of 1 and square root of 4, like the square root of 2, that ends up being another kind of decimal that doesn't end or have patterns. Or the square root of 3, or the square root of 5, or the square root of 6, or the square root of 7, or the square root of 8, all irrational, but the square root of 9 is rational because that equals 3. See? So some of the square roots qualify. Now, what we can do is we can do one more thing, and that is we can continue this here, and let's look at the world of, we have what goes inside is whole numbers. These are the numbers like 2 and 8, 57. Okay, those are whole numbers, and I'll put a circle around that. And then outside of that, we have integers. And the integers would include the whole numbers, 2, 8, 57, and so on, but also 0, and negative 6, and negative 72, and so on. And I'll put a circle around that. And then we have the rational numbers. And that includes those numbers I was just talking about. But it also includes the whole numbers and the integers. So if it's not a whole number or an integer, we're talking about fractions like the 2/3, like the negative 1/4, like a decimal that comes to an end or repeats, like 0.62, something like that. All those are, so that's what we look at. So if we have a whole number, it also is an integer, and that's also a rational number. If you have an integer, it might not be a whole number. Like negative 6 is an integer, not a whole number, but it is still a rational number. You see, so I would use this here, and let's bring this over here and try to use it in our problem. So pi over 2. Well, first off, I told you that pi is rational, and so we're just going to go right to irrational right there. But we can use all the work that we have so far. So it is definitely irrational, and I will choose that. Okay, so square root of 25. Well, let's take a look at what we have here for that. The square root of 25, where would that belong? The square root of 25 is a whole number because the square root of 25 is 5. And 5 is a whole number. And if it's a whole number, that means it's an integer and a rational number. So it's all three of these. And I will move this over now. So the square root of 25, that is equal to 5. And 5 is, I said, a whole number. It's an integer and it's a rational number. So it would be, let's choose all those that apply. And I'll check that. Maybe I won't. Oh, whoops. Okay. All right. Let's try another. Ooh, here's a big old decimal here. Let me erase this here. So this is a repeated decimal. It's a decimal that repeats. This is equal to 0.25726, and it just keeps on going. Now this is definitely rational because I brought that over here. Let me bring this here. And within this, we can see that this is a repeated pattern right up here. Remember when I said if you have a repeated pattern right here, this repeats here, and this is a pretty easy pattern, but this is still a repeating pattern. That's definitely rational. So I will bring this over here, and we have rational. No, it's not an integer, rational, but it's not an integer because integers are the positive and negative whole numbers. And this is a decimal. All right. Next, negative square root of 81. Well, we got to know, just because you see a square root doesn't mean it's going to be irrational. That is equal to negative, and the square root of 81 is 9. So negative 9 is an integer. And so we know that this is an integer, but it could be more. And if we look at my table here, the integers also qualify as rational numbers. So we'll bring this over, and this is a rational number. But it is not a whole number because it's negative. If it was 9, then it would be positive. Okay. And the square root of 2, you know what? I think I already showed the square root of 2 is irrational right there. So let's just jump right to that. It's irrational. And when it's irrational, it's nothing else. It's just irrational. And I'll erase that. And that is irrational. All right. We're getting it. And what type of number is 1 point with a 0, 0? Well, definitely. Could it be a whole number? Wow. I have to be honest here. I'm a little stumped because 1 is a whole number and 1 is an integer. Well, I know for sure that this is rational. That is absolutely for sure. We might be learning something here. So this is about to get real. Um, and I'll tell you my thinking about this. Whole number, 1 is a whole number, but what 1.00 repeating? Oh, whoops. That's rational. It's definitely rational, not irrational. Um, I'm going to say it's only rational because integers don't have decimals and whole numbers don't have decimals. So I'm going to go with this. You're almost there. Okay. Well, then they're saying that 1 is an integer and a whole number. I guess that's what they're talking about then. So let's see. All right. So that's what they're talking about then. It was a little tricky that they had decimals in there, but anyway, there you go. Oh, you know what? Might as well do one more, huh? So this one's going to be easy. I know that 2/3 is 0.6 repeating because if you go back to this over here, remember the 2/3? This came in handy. 2/3 is 0.6 repeating. So if I come back to this, that means that this is equal to 3.6 repeating. Now this is definitely rational. I mean, a rational number is a fraction of integers. But we can see quite easily at this point that this is not a whole number. It's not an integer because you got decimals there, but it is rational. That's all it could be. Done. And yes, thank you very much. All right. Well, I hope this has been helpful for you. Good luck.